Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in the last video I introduced to you the construction of Opamp. I told you Opamp is nothing but a multi-stage amplifier which had 4 stages. Input stage, which was a dual input balanced output differential amplifier. Intermediate stage, which was dual input unbalanced output differential amplifier. Level translator, which was bringing the DC level in the signal to 0. And the output stage, which was a push-pull complementary amplifier. And then I showed you mathematical model of Opamp. In this mathematical model, I told you V0 is equal to A into VD, where this difference voltage was the difference of the non-inverting and the inverting input. Okay. But in that also we saw the transfer characteristics. In transfer characteristic, I told you V0 can never exceed supply voltage. We saw that, due to which the linear region of characteristics is very small. Okay. Then we also talked about ideal Opamp. In ideal Opamp, I told you the input resistance tends to infinity and output resistance tends to 0. Due to infinite input resistance, the current at the input terminals was equal to 0. Also, it had open loop gain tending to infinity. So that is what we saw in the last lecture. In this one, we will talk about open loop configuration of Opamp. Open loop means we are not using any feedback circuit. Okay. So that is, there is only one path going from input towards the output, but there is no path that comes back from the output to the input. There is no terminal connecting or no component connecting the output to the input terminal. Okay. So the first stage or the first configuration is called as differential amplifier. In BJT also we talked about differential amplifier. So differential amplifier, what does it mean? When we talk about differential amplifier, it means it amplifies the difference of two voltages. Okay. But now what you have to see is, this is the positive or the non-inverting input. This is negative, which is also called as your inverting input. Okay. So what I will assume is that there is no current at the input terminal. This you can almost always assume no input current can always be assumed. This is an assumption which you can apply to any question that you are solving. So what is the voltage of positive terminal? Since there is no current in Rn1, there is no voltage drop. So V positive is V in 1. What about voltage of negative terminal? Again, due to zero current, no voltage drop in Rn2. It is V in 2. We know that by mathematical model, V0 is AD. AD is also called as differential gain. Differential gain means the gain multiplied with the difference of the inputs. Positive voltage minus negative voltage. Or you can say AD V in 1 minus V in 2. But as I have told you, the value of V0 should always lie between the two supply voltages minus V supply and plus V supply. It can never exceed the supply voltage. So you always have to check after finding the output whether or not it is exceeding the supply voltage. If it exceeds the supply voltage, you will set the value of V0 at the supply voltage. That is, if V0 is coming out to be more than V supply, then you will say V0 is V supply. If it is less than minus V supply, you will say V0 is equal to minus V supply. Okay, but you will never have a value of V0 which is beyond the value of supply. The next configuration is called as inverting amplifier. Now, why is it called inverting? That I'll tell you shortly. First assumption, no current enters the input. If no current or no input current is flowing in an op-amp, okay, also one thing, I have told you, you can always assume that there is no input current, but I have not said that there is no output current. Don't think that I forgot to tell you that, okay. There is no condition in which you can say output current is 0. Output current can be positive or negative, or it can be 0. So we don't know what is the output current, and you can never assume the value of output current. You can only say we are assuming that input current is 0. If input current is 0, there is no voltage drop across Rn. If there is no voltage drop across Rn, the voltage of negative terminal is Vin. What about voltage of positive terminal? It is 0. Now we know V0 is differential gain. Differential gain means the gain multiplied with the difference of the two inputs. Positive terminal voltage minus negative terminal voltage. AD 0 minus V in minus AD into V in. Okay. So now if you see that if V in is positive, V0 is negative. If V in is negative due to minus sign, V0 will be positive. So V0 has opposite polarity to V in. V0 is opposite to V in, which means it has 180 degree phase shift. Okay. So V0 has 180 degree phase shift with respect to V in, and that is why it is called as inverting amplifier. Okay. Just like in BJT we had common emitter amplifier, it was providing 180 degree phase shift. In MOSFET we had common source amplifier, that was also providing 180 degree phase shift. Similarly in op-amp, when we are talking about inverting amplifier, it is providing output opposite to the input, or you can say 180 degree phase shift in the output. The third configuration in open loop is the non-inverting amplifier. Now, as you might have understood with the name, non-inverting means it will not invert the output. If it does not invert the output, then how much phase shift will it provide? It will provide 0 degree phase shift. Okay. Or you can say output will have same polarity as input. Let us see how it is done. Again, the first thing that I'll assume is no input current to op-amp. Okay. That you can assume in ideal as well as practical op-amp, that there is no input current. So if it is 0 ampere, what is the voltage across Rn1? 0 volt. So if I ask you what is the positive terminal voltage, it is V in. What is the negative terminal voltage? It is 0. Now we know V0 is, by mathematical model, differential gain into positive terminal voltage minus negative terminal voltage. That is AD V in minus 0, or you can say AD V in. Okay, it is actually V in 1. Now as you can see, there is no negative sign. If there is no negative sign, it means it provides 0 degree phase shift, or you can say V0 has same phase as V in. Okay. So that is what is the meaning of non-inverting amplifier. That means it will not invert the output, and output will be in same phase as the input. In inverting amplifier, we saw there is a minus sign in the output. So input and output will always have opposite polarity, and here they will have the same polarity. So generally in open loop configuration, we only talk about 3 amplifiers: differential, inverting and non-inverting. Now when we want to realize a closed loop, we talk about feedback. First of all, let us understand the meaning of feedback. Feedback is basically made of 2 terms, feed and back. So it means feed the output signal back to input. So what happens is that some portion of the output signal is being reapplied at the input, and that is called as the feedback system. Now see here, we are taking the output, and then we are feeding it back to the input. This is basically your summing element. Okay, this we very well study in control systems. See, we have marked positive terminal with the input, that is, it is V in, and suppose this voltage is Vf. It has plus as well as minus sign. That is, there are 2 possibilities. This suppose is Vd. Vd is V in plus minus Vf, or let me call it as Ve, because most of the times it is called as error signal. V in plus minus Vf. If you take Ve as V in plus Vf, it is called as your positive feedback, that the feedback voltage is being added to the input. If you take subtraction, it is called as negative feedback, that is, feedback voltage is being subtracted from the input. Okay. Now as I told, not the entire input is fed back, but only some portion of the input, and that portion is represented by this feedback factor. If this voltage is V0, this feedback factor is called as beta. So Vf is always equal to beta V0. So feedback is not completely V0, but a factor multiplied by V0, and that factor is called as beta. And in the forward path means the path going from input to the output. So whenever I talk about forward path means the direction of the path is from input to the output. What about feedback? It means the direction is from output towards the input. So feedback is nothing but the output signal is fed back to the input, and it is compared with the input signal to generate a error signal. Okay, so feedback always generates a error signal, and this error represents the difference between the input signal and the feedback signal. Now what is the purpose of feedback? The question that comes to mind is why we are applying feedback. The first thing is to control the gain of the amplifier. I told in the first lecture itself that the gain of Opamp is very high. We want it to control by means of external components. That is why we are applying feedback. Second, to control bandwidth. Bandwidth I have told in frequency response. It is the range of frequencies which can be amplified by the amplifier. So that region I was calling as midband. So midband was the range of frequencies that experience constant gain. But in low frequency and high frequency, due to capacitances, the gain will change. So bandwidth is simply the range of frequencies which can be easily amplified by the amplifier. Okay. The third reason is to reduce distortion. The distortion in output signal is reduced. Reduced effect of non-linearity. Not every component in your circuit will be linear, and their effect can be reduced by means of this feedback. Reduce environmental effects. Okay, we want to reduce the effect of temperature, humidity, pressure, all these things we want to reduce, and that is why we are using the feedback signal. Okay, so whenever we are using the feedback signal in any system, it is called as the closed loop system. Whenever we are not using the feedback system, we are calling it as the open loop system. And I have told you why we are using the feedback. We want to make the system more stable, or it should be less sensitive to the atmospheric condition, less sensitive to the distortion, non-linearity, and the gain should be controlled. Okay, I want the gain to be controlled, and that is why we are using the feedback. Now, as I have told you, there are two nature of feedback, negative feedback and the positive feedback. Negative feedback means the feedback signal should be subtracted from input signal. Sometimes this input signal is also called as reference signal. So we want that the feedback signal should be subtracted. Now, when it is subtracted, I told you the error signal is input voltage minus feedback voltage. So this error signal is reduced due to VF. Now see this output V0. Suppose this open loop gain is A. What is the input to the amplifier? VE, and the gain is A. So output V0. How you can write V0? A into VE. So I can say V0 also reduces. So due to negative feedback, V0 decreases, and hence the gain AF. AF means gain after feedback. V0 by Vin also reduces. So if you want to reduce the gain of the amplifier, then you have to use the negative feedback. Okay. Now why we want to reduce the gain? To increase the stability. Because I told you the open loop gain is very high. Okay. And if it is that much high, there are high chances that the output will saturate. I told you the linear region of the amplifier is very small. Most of the times it will saturate. And saturation is undesirable because we want output to be proportional to the input. What is the basic purpose of amplifier? To produce output proportional to the input. But if the output saturates, then output will become constant, which is undesirable, and that is why we want to reduce the gain. Okay, so it will increase the stability, it will increase the bandwidth, because we know in frequency response I told you gain into bandwidth is constant. If gain is being reduced, your bandwidth will increase. Okay. And you can compare it with a real life situation. If I am giving you negative feedback about your performance, if I am saying your performance is not up to the mark, then how you will feel? You will feel very demotivated, and once you feel demotivated, your energy will reduce, your performance, or basically your excitement will also reduce. So same thing is happening here. By applying negative feedback, the effective value of input is reducing. Okay, and this negative feedback is used in case of amplifiers. Now how to find the gain in a negative feedback? See like this. V0 I am calling it as AVE, A into Vin minus VF. And I told you this VF is called as beta V0. Beta is the feedback factor I told here. If beta is the feedback factor, then VF will become beta times V0. That is the gain of this feedback path. So if you apply this in the above equation, A Vin minus beta V0. Collect the terms of V0 on the left hand side. It is equal to A Vin, which means this ratio of V0 by Vin, how much will it become? A over 1 plus A beta. In case of open loop, see, if beta equal to 0, that is open loop, the gain will come out to be equal to A. Put beta equal to 0 here, it will be A. But if beta is non-zero, gain is less than A, because in the denominator it is being divided by a number higher than 1. So that is why gain reduces in a negative feedback amplifier. Now see, one thing that will happen is how this negative feedback is being realized. So this RF is working as feedback. In this circuit, this RF is working as feedback because it is connecting the output to the input. But which input terminal? It is connecting to the negative input terminal. So whenever you connect it to the negative input terminal, it is called as negative feedback. Okay. Why it is negative feedback? Understand one point of mine. See, this amplifier, which kind of amplifier it is? Check. The input is connected to the negative terminal. So it is an inverting amplifier. Is my point clear to you? Previously, just now I have told you in open loop configuration, if input is connected to negative terminal, it is inverting amplifier. If input is connected to positive terminal, it is non-inverting amplifier. So what kind of amplifier is it? Inverting amplifier. Which means V0 is minus gain into Vin. It is opposite to Vin, which means the feedback voltage, which is beta V0 minus beta K Vin. So that means feedback is opposite to Vin, and hence it is negative feedback. If Vin is positive, then feedback is negative. If Vin is negative, then feedback is positive. In both the cases, feedback will oppose Vin and it will try to reduce Vin. Okay. So what happens is, whenever feedback is applied or negative feedback is applied, if input is positive, feedback is negative, so net voltage will be reduced. Similarly, if input is negative, feedback is positive, again the net input will be reduced. In both the cases, net input reduces, and that is why it is called as negative feedback. And other name of such kind of feedback is degenerative feedback. So what you have to remember about negative feedback? For negative feedback in Opamp, we have to connect feedback at the negative terminal. Secondly, the gain of the amplifier reduces in case of negative feedback. This much, if you remember, is sufficient. Next, let us talk about positive feedback. This positive feedback is also called as regenerative feedback. Previously, I told you in positive feedback, the error signal is nothing but it is input plus feedback. So VF increases the effective input. Okay, feedback is increasing the effective input. So what will happen? let me show you. Previously I wrote V naught is simply A into VE. How I wrote this? See this? This is VE. This open loop gain is A. So V naught is how much? A into V. Which means A V in plus VF. But we know by feedback VF is always beta V naught, where beta is called as the feedback factor. So V naught is A V in plus beta V naught. Collect the terms of V naught on the left hand side. 1 minus A beta is A V in, which means the gain of the amplifier V naught by V in is A by 1 minus A beta. If beta equal to 0, then what is the gain? Gain is equal to A. If beta not equal to 0, the gain is A over 1 minus A beta. Now in the denominator there is a term which is less than 1, so this gain is greater than A. So the gain increases in positive feedback. Are you getting my point? The gain will increase in positive feedback, and we wanted to stabilize the gain. Think like this. Why did I apply feedback? I told you that the open loop gain is very high. It is unstable operation. I wanted to stabilize it. But in positive feedback, what have we done? We have increased the value of gain. Already the gain was very high, but we have still increased the value of gain. So that is why it cannot be used as amplifier, but it is used as oscillator. So positive feedback is used in oscillator application because we have not increased, or sorry, we have not stabilized the value of gain. So we will be using in the it in the oscillator. Now how to implement positive feedback is connect feedback. Connect this feedback to positive terminal of Opamp. Now see this. Here the feedback is connected at positive terminal. Input is also connected at positive. If input is connected at positive terminal, it is an example of non-inverting amplifier. Okay. If input is connected to the negative terminal, positive terminal, it is a non-inverting amplifier, which means V0 and Vin will be in same phase. V0 is KV in, and we know VF is beta V0 or beta K V in. So feedback and Vin are in the same phase. VF and Vin are in same phase, so they will be added up. So whenever you want to implement positive feedback, connect the feedback at the positive terminal, and when you want to implement negative feedback, connect the feedback at the negative terminal. In negative feedback, I told you it was trying to reduce the input signal, but positive feedback tries to increase the input signal. If input is positive, feedback is also positive. Net input will increase. If input is negative, feedback is also negative. Net input will again increase. So positive feedback tries to increase the input signal and hence increase the output, and negative feedback tries to reduce the input signal and hence reduce the output. That is why in most of the positive feedback application, the output will always be VSAT, because if the gain has become high, the op-amp will saturate and output will become equal to the supply voltage. It will not be less than the supply voltage. So if you want to implement an amplifier, you will use negative feedback. If you want to implement an oscillator, you will use positive feedback. Now let us discuss one of the most important concept. This concept is most important in your op-amp topic. If you understand it very clearly, you will be able to solve 90% of the problems based on op-amp. Okay. So listen carefully this concept of virtual ground. Now what does this virtual ground say? First of all, can only be applied if open loop gain tends to infinity. Okay, if your open loop gain is very high, it tends to infinity, then only you can apply this concept of virtual ground. So let us see. In negative feedback, what I told? In negative feedback, we just now derived the gain, right? So tell me, what was the gain V naught by V in? It was A over 1 plus A beta. Now when we are talking about the amplifier Opamp, in Opamp, the difference in the positive and negative voltage is Vd and output is V naught. So in linear region, if we are operating in linear region, V naught is A Vd, or you can say Vd is V naught by A. So what is Vd? V naught is how much? A V in over 1 plus A beta into 1 by A. So V in over 1 plus A beta. Now if I say that open loop gain tends to infinity, then what will this Vd become? If A tends to infinity, the denominator is infinite, so it will become 0. Now this Vd is actually the difference of positive terminal voltage and the negative terminal voltage. So you can say positive terminal voltage is equal to negative terminal voltage, and this concept is called as virtual ground. Virtual ground means approximately the voltage of both the terminals are equal, or you can assume, if the voltages are equal, what we can assume? We can assume that both terminals are shorted together, because same voltage means short circuiting. But remember one thing that I have told you, this concept can only be applied when your open loop gain is infinite. Okay, also I have assumed that Opamp is operating in linear region. This mostly happens in case of negative feedback. I told you in positive feedback, what did I tell in positive feedback? In positive feedback, the gain increases. If the gain increases, the output voltage will increase. If the output voltage increases in the characteristic, think like this. If output voltage increases, it will end up in the saturation region. So saturation occurs in positive feedback. That is why we cannot apply the concept of virtual ground. When can we apply the concept of virtual ground? We can only apply the concept of virtual ground in linear region, and linear region is only observed in negative feedback. Let me take an example how you can use this virtual ground concept. In the circuit, if you see, in this circuit, positive voltage is 0. If I say what kind of feedback is there, see, this feedback is connected to negative terminal. So whenever feedback is at negative terminal, then it is called as your negative feedback. In negative feedback, what we can apply? We can apply virtual ground. Why we cannot apply in positive feedback? Because in positive feedback, Opamp operates in saturation region, and the basis of virtual ground is the operation in the linear region. Now, by virtual ground, what I know? By virtual ground, I know that positive and the negative terminal voltage must be equal. So they both will be 0. So this voltage is 0 volt. What is this current I? this current I can now be written as V in minus 0 by R in. So it is V in over R in. Now we know there is no current input to the op-amp. So this I current will flow through this RF. So how you can write I again? I will be, it always goes from high to low voltage. So which will be the high voltage? 0. Low voltage V naught. And we know it is V in by R in. So you can say V naught by V in is minus RF by R in. So that is how by the use of virtual ground we can find out the gain. And as you can see, it depends on what does it depend on? External resistance, right? It does not depend on op-amp parameter. If it only depends on external resistance, then it means we have realized the objective. Our objective was to make gain independent of the open loop gain, and that is what is happening with the negative feedback. So if I summarize what we have covered in this video, first I told you about open loop configuration. In this open loop configuration, we saw three types of amplifier: differential amplifier, inverting amplifier, and non-inverting. Then we talked about feedback. I told you why do we apply feedback? To stabilize the gain, to increase the bandwidth, and to make the gain independent of the environmental condition. This will again come back when we will be studying the concept of feedback amplifier. There we will discuss this more in detail. The why part I have skipped, I haven't gone into the details. We will cover it once again when we will be studying feedback amplifier. Then we studied about negative feedback. In negative feedback, we saw that gain becomes A over 1 plus A beta. Then we talked about positive feedback. There the gain became A over 1 minus A beta. How to recognize the feedback? If feedback is connected at negative terminal, it is negative feedback. If it is connected at positive terminal, it is positive feedback. Okay? And then I have told you about the most important concept in op-amp, that is the concept of virtual ground. Here I have told you two conditions, negative feedback and the second one, A tends to infinity. In that case you can say the voltage at both the terminals will be same or the differential voltage will be 0. Okay. So that is what we have covered in this lecture. Later on when we will be studying about closed loop configuration of op-amp and the circuits based on that, this concept of virtual ground will be applied again and again. So this is the most important concept in this chapter. Thank you.
For 12 months the pricing is 3250, but if you apply the code Ankit ESE it becomes 27225. For 18 months it will be 34650 and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for iconic for 12 months, it is 5250 with code Ankit ESE it becomes 45225 and 2 year subscription becomes 66600. So the choice is your, but take a longer duration subscription for more cost effective solution and to give GATE and ESE at least 2 times so that if you once crack GATE in the next attempt you can even get ESE. And other than that my friends, you can download the Unacademy learning app right now because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these two channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.